and probably a quiz on Friday. Okay, since you got here a little late. Okay, so on this example, and this is example 4.8 from your book on page 73, excuse me, we're given this, better get my mouse squared away here. We're given this, this beam that has some evenly distributed load on it right here, 30 kilonewtons per meter over 6 meters. So we know then that that's going to be what? 30 kilonewtons per meter times 6 meters. Meters cancel out, and you're left with what? 180 kilonewtons, right? So that would be what would be showing up down here. And then that force is going to be right in the middle of that 6 meters. So it'll be 3 meters from A, or whatever that value is from B.
As long as it's even distributed perpendicular to the beam like that, it's always the center. It's always divided by 2.
That's correct. It's always
on the triangles when you do the 2/3.
on the triangle. You do the 2/3 or 1/3, depending on the shape of the triangle. That's correct. Josh,
Where are you getting the? You get 180 because wouldn't 30 minus 6 be like 24? I think.
3 times 6 is 18, right?
6.
Yeah, it's times. Okay, that's what. Yeah, that's what that's supposed to be a dot,
Okay.
as opposed to my minus will be a little bit more pronounced than that. I try to be at least. And if my writing doesn't match up to what you think sometime along the way, you can always smack me on that too. Okay, but I try to do the best I can with this pen. So yeah, that's 180. And again, the meters cancel out, and you're left with kilonewtons. So we have the right units. Okay, so we've got that force to contend with. Then we've got this 45 kilonewtons and this 90 kilonewtons here. Really, once you get this turned into 180 kilonewtons at 3 meters in here, once you get that, it's just like the other problems you were doing. It's exactly like the other problems. So that's the only key on this one. Now, back to Jeff's question, if that were, if that were tapered, unevenly distributed load, if you will, then you would have to do the 1/3 as opposed to half. But that's the only difference as far as that's concerned. Okay, so let's erase that out of there. That's not part of the problem. Okay, so then what are we going to do? Well, we're just going to do, we'll do sum the forces in the X. Let's see if we'll have enough room here. Equals 0, right? We want it to be in equilibrium. That's what this chapter is all about, right? So we've got 180 kilonewtons. Actually, I'm gonna try to conserve space here. I'm not gonna put the unit in there. And that's going down, right? So it's a negative 180 minus 45 kilonewtons. Oh, and I just got done saying I wasn't going to put those in there, didn't I?
Does that say forces in the X?
Yes. What, are you saying you can't read my writing?
Isn't that forces in the Y then?
Oh, it is. Thank you. Force. Yeah, in fact, I really should back up. I'm actually going to redraw this free body diagram. I think would be better. And they've got it drawn right here. The only thing I don't like is they left the evenly distributed load in there. I was trying to actually hide that. So let's redraw that free body diagram. If I could just keep that where I could see the forces. Okay, so if I were redrawing this, in fact, I'm going to draw it right here, and then I'll use the space below it. I would have AY. Thanks for catching that, Clark. I'd have just kept on going. AX. And if I'd have done this first, I might not have done that, potentially. BY. Probably going up, right? BX, we know is 0. It's on a roller, right? Then we've got 180 kilonewtons because of that evenly distributed load. That's 3 meters. Then we've got 45 kilonewtons. And the distance, let's see, that'd be 3 plus 2 is 5 right in there.
And wouldn't it be 2 plus 6?
Huh?
Yeah, what is it, 2 plus 6?
Okay.
45?
All right. Well, from A it would be
Oh,
2 plus 6.
I see what you're
I was
saying.
just
Yeah,
saying
yeah, yeah. Okay.
from here over to here
Gotcha.
is 5, but the two of them is 8. So
Either way.
yeah. And I would, no, I'll have to go 8, okay? But I was just trying to use what I had here at the time. Okay, and that's 90 kilonewtons. And that distance is showing up as 2.5, right? And then they're showing me a distance here of 1.5. Jeez. Now, what I would suggest then, yes, is I would do this. That's going to be 8 meters, right? We're not in drawing class, so we can double dimension, if you will. This one is what, 8, 10.5. Typically, I like to come from the left side. You don't have to. Sometimes, well, and you may want to do it from the right side just to check your work, right? Let's see. That in the overall. Let's see, 12. Okay. So let me get these two guys here. Okay, so now that's the free body diagram. Everybody okay with that? Looks about right. Do what? Do what? What? How did I get what?
The 180 kilonewtons.
Oh. Let me back up here a second. 30. It was given as 30 kilonewtons per meter, right? Times 6 meters, and that's where the 180 comes from. And your meters cancel out, and you're left with kilonewtons. Okay. And I don't have my hearing aids turned up, so you have to talk up. Okay. So there's our free body diagram. So now we'll do forces in the X, and we'll do it right this time. So we do summation of the forces in the X equals 0 equals what? AX. That's all we have, right? So I just put a box around that. AX equals 0. And on the quiz, I will ask you for all those reactions. BX, we could put a box over here on that, really. If I could get to it. BX is 0. And actually, what I normally do is I put a place for you to list the different answers. Okay, so I'll put a place for you to have AX equals, and then there will be a blank spot, and I'll expect you to write it in there. So everything that I'm asking for will be listed in a spot so that everybody will know this is what I'm looking for. Because when we get to structures, when we get to the trusses and start figuring out different trusses and what their members are carrying, a lot of times there will be one or two that I won't even ask for, but sometimes you have to figure them out to get the other answers, but I won't count them. Okay, so that's always a question that gets asked come test time. Well, wait a minute, what about that member? If it's not in that list, then I don't expect it. It's typically what goes on there. Okay. So far, sum of the forces in the X. So then we'll do a summation of the forces in the Y equals 0. Again, keep it in equilibrium. And now we'll use that 180. Negative 180 minus 45, wasn't it? Minus 45. And again, these are all kilonewtons. minus 90 plus by. Okay, it is, that force is going up. That's what we're trying to find, isn't it? We left one out, didn't we? Plus AY. And normally I would put AY over on the other side, but I forgot it. I would put it first. I just list them in order so I don't screw up and forget one, which I did. So we've got two unknowns, so we punt that, if you will, for football term, and move on. So moving on is we'll do a sum the moment about, I like to do it about point A. You can do A or B, it doesn't matter. I will solve for A and B on the solution so that if you choose B instead of A, then I've got the answer for that too. So it doesn't make any difference to me. So I'll leave some space in there because I know I've got to come back to this. Okay? So I'll leave some space in there and I'll do sum the moment at A and make that equal to 0. It's got to be in equilibrium. So we know we've got, well, AY and AX both go through the point A, don't they? So we can't use those. Excuse me. Well, we've got 180 kilonewtons and it's 3 meters away from A, right? So we'll go 180 kilonewtons at 3 meters. Oh, I started to put feet. Right? Somebody tell me that's not right.
Minus.
Yeah, it's got to be negative, doesn't it? Notice I left a gap there. Just for that. Again, it's pushing down, yes, but more importantly, from where you're sitting, it's making that thing go clockwise, right? Clockwise negative. Okay? Same thing with the 45. It's negative, it's making it go clockwise. Negative 45 times, what was it, 8 meters? Right? Minus, the next one was 90, wasn't it? And it must be 10.5 meters. Plus 12, or let's say by times 12 meters. Wish I could make that just a little bigger. On what you'll be able to see on the other one. But so we had 3 meters. This was going down, which makes that thing go clockwise, negative. Clockwise, negative. Clockwise, negative. Boom. Counterclockwise, positive. That would almost tell you, if you had guessed that to be pulling down, to keep that in equilibrium, that would almost tell you that, yeah, we probably screwed up on our direction, because everything being negative, you can't flip something to the other side, so and come up with a positive answer. So you would almost know that immediately that you guessed the wrong direction. Okay, especially on this one. So we could leave by where it's at, so it's 12 by equals, and since we had this equal to 0, we can throw everything else on the other side of the equation, right? All of those become positive. I'm going to give myself a little more room here. Make it easier for you to see. And what does that come out to be? Hopefully, it comes out to be something like 153.8 kilonewtons. Oh, well, that's what it would ultimately end up being, but that's not quite what it would be, would it? I guess we'll have to get the calculator out. So 180 times 3 plus 45 times 8 plus 90 times 10.5. So that's like 1845. 1845 kilonewton meters, right? It's not kilonewtons per meter like people were trying to put on the test. Kilonewton meters. It's like a multiplied type of thing. Okay? So then you take that number, if you wanted to find out what by was, you would take the 1845 kilonewton meters divided by 12 meters. The meters cancel out, so we are left with kilonewtons, which is what we wanted, right? By equals 18 or 184, no, 1845. I didn't write it down, did I? Got carried away getting the units in there. 1845 divided by 12, 153.75 kilonewtons. Now we're not done though, are we? Up. That would be my answer for that. It come out the same as his. Somehow, yeah, they rounded up to 18 or 153.8. Now having that, we can go back up to this equation. What was that? 153.75. That was BY, right? So we can scratch this out and say 153.75. It came out the right direction, right? Came out a positive number, so it was the right direction. It was going up, so we don't have to change anything on this. Okay? So now we'll leave AY where it's at. Throw everything else to the other side of the equation. We got 180 plus 45 plus 90 minus 153.75. 161.25. 161.25 kilonewtons. We said it was going up. It came out a positive value, so it is going up. It makes it easier for me to grade if you put a box or a circle around it, so I can see, you know, okay, this is where that equation came from, or where that number came from. That's the equation they used. Especially if you've got a bunch of other scribbling on there, it makes it kind of difficult. So go easy on the old guy, okay? But in this problem, the only difference there was you had to break this 30 kilonewtons per meter at 6 meters. You had to put that into a concentrated load. It's essentially what you were doing there, isn't it? That's the only trick of this one. Questions?
So you're done with, that's the whole problem right there?
Yep.
On that, yeah.
Yep. Now you could, if you chose to, if you had enough time, you got the whole quiz done, you could go in there and say, okay, I'm going to do a sum the moment at B.
Yeah, but that's just checking your work, basically.
Right.
Yeah.
And you could go in and you could even list the BY. Well, actually the BY wouldn't show up, but AY, right? Because if you did the moment about point B, you would have this 90 kilonewtons at 1.5, right? And that's making it go counterclockwise, which is positive. So 90 times 1.5. Then you've got the 45, which is making it go counterclockwise, which is positive. Again, BY went away because it's going through the point, right? So let's see, 45 times what, 3, 4. So it would have plus 45 times 4. And what, the 180? And that would be what, let's see, we got 4, 6, and 3 is 9. So plus 180 times 9 minus, right, AY, which we know the value for that now, but AY is pushing it up, making it go clockwise, which is negative. Okay, and we said AY was 161.25. So 161.25 times 12. And if you do the math on that, it should equal 0. I'm not going to do it. I'm afraid to do it, but it might not equal 0. Or it may not equal 0 somewhere along the way, depending on your rounding. It might end up being like 0.0002. That's 0. Loved it.
Can you explain why the 90, 45, and 180 are positive this time?
Yep. But I have to go back to the picture. Okay? So in this picture, if we're rotating about this point B right here, this one does this, which is counterclockwise. Counterclockwise is positive. Same thing on this one. And again, think in terms of if I put my finger there and I tied a string on it and tried to pull it down, that's what that string is going to, or a compass, if you will. Same thing here. And then this one makes it go counterclockwise, which would be the opposite, so positive. Okay? Or well, I'm sorry, I had that all backwards. These going counterclockwise was positive. This one going clockwise is negative.
Got it. Thank you.
Yeah. Anything else? Anybody punch that in, make sure it did equal 0? It should have. So again, that's not a whole lot more difficult or different than the other ones we did for homework. The only thing that's going to throw, and I think, did we do some for homework that had an angle on them? Didn't do any that had an angle? And we will